We are living in a pretty wild time. We've got AI that can write code, and honestly, it's getting better and faster than a lot of us humans. It's a huge leap forward for sure. But, and this is a big but, it brings up one single massive security question that's kind of holding back a full-blown revolution.
And that right there, that's the billion-dollar question, isn't it? I mean, it's one thing for an AI to spit out a chunk of code that solves a problem. It's a completely different thing to actually run that code on your own machine, let alone in a live production environment. How can you possibly trust it?
Okay, let's really dig into this because this is the core of the problem we need to solve. We're talking about taking code from a source that has zero concept of trust or safety or anything like that. Just think about it for a second. An LLM is just predicting the next word, the next token in a sequence. It has no idea about security or malicious intent. It could accidentally generate code that wipes your hard drive, leaks your customer data, or opens up a nasty backdoor into your system. Just copying and pasting that code is a recipe for disaster. What you need is a sandbox, right? A kind of digital jail where you can run this code and it's completely walled off from doing any real damage.
And that, my friends, is exactly where a tool like Runner Codes comes into the picture. It was built from the ground up to solve this very specific and very modern problem.
So let's break that down. The magic words here are secure execution environment. What Runner Codes does is it takes a piece of AI-generated code and runs it inside something called a Firecracker micro VM. Just think of it as a tiny, single-use, completely isolated virtual machine. The code is essentially in its own little digital prison. It can run, but it can't touch or even see the underlying system.
So what does this design give you? Well, you get some pretty incredible benefits. First, you get that super strong security isolation we just talked about. But on top of that, you also get extremely fast boot times, which is absolutely critical for any kind of interactive application. It has a tiny resource footprint, which makes it incredibly efficient, and it supports multiple programming languages, so it's really versatile.
So what's the secret sauce here? What's the tech that makes all this possible? Well, it's called Firecracker, and it was actually developed by a name you'll definitely recognize, Amazon Web Services. Yep, you heard that right. This isn't some brand new experimental thing. This is the same battle-tested technology that powers massive, secure services like AWS Lambda and AWS Fargate. A virtual machine monitor, or VMM, is basically the software that creates and runs virtual machines. And AWS built Firecracker from the ground up with two main goals in mind: speed and security.
Now, what's truly mind-blowing is just how fast and light Firecracker is. I mean, when you hear a virtual machine, you probably think of something slow, heavy, and clunky. But these next couple of numbers are going to completely change how you think about that.
First up, speed. A Firecracker micro VM can boot up in about 125 milliseconds. That is just over a tenth of a second. It's so fast you can literally create a brand new, fully isolated virtual machine for every single function call and then just throw it away instantly. It's wild.
And what about resource usage? Well, the memory overhead is just 5 megabytes per micro VM. That is ridiculously small. This level of efficiency means you can run thousands of these isolated environments at the same time on a single server.
So here's the most important point. How is this different from something like Docker? Well, containers are great, but they all share the host machine's operating system kernel. And if there's a single vulnerability in that kernel, you could have what's called a container escape, where malicious code breaks out. Firecracker just completely sidesteps that problem by providing true hardware-level virtual machine isolation. It's a fundamentally stronger, more secure boundary.
Okay, so that's the what and the why. Now let's get to the fun part and see how this actually works in practice. How would you, as a developer, actually use this thing day to day?
Well, it's beautifully simple. You've got two main options. You can use a command line interface, which is perfect for quick tests or some local scripting, or, and this is where it gets really powerful, you can integrate with it through a standard HTTP API. This means you can build this secure execution engine directly into any application you can dream up.
So what happens when you run a simple Hello World script? You don't just get the text Hello World back. No, you get this really nice, structured JSON object that's just packed with useful information.
And this is just brilliant. The standout field that gives you your actual output. Stand_R will show you any errors that popped up. The exec code is super important. It tells you if the code completed successfully. 0 is the universal sign for success. And you even get these precise performance metrics, like how long it took to prep the VM and how long the code itself actually ran. It's everything you need, all in one clean response.
Okay, so let's zoom out for a second and put all the pieces together. We now have a way to take completely untrusted, AI-generated code and run it in a super fast, super light, and super secure sandbox. So, what does that actually unlock? What does this mean for us?
Here's the bottom line. Tools like runner codes are the missing bridge. They're what connect the incredible power of code-generating AI with the real world safely. Developers can now build applications that let users type a command in plain English, have an LLM write the code to make it happen, and then run that code on the fly, all without compromising the security of their core systems.
And that really is the most exciting part of all of this. This opens up a whole new frontier. Imagine AI coding assistants that don't just suggest code but can safely run it for you and show you the result instantly. Or data science tools where you can just write natural language queries that get turned into code and executed securely. The potential is just massive. So the question isn't if we can run AI-generated code safely anymore. The real question is, now that we can, what new applications are you gonna build?